Hello, this is Ms. Stabnick, and this is part 2 of the lesson called Introduction to Algebra Tiles. So in this lesson, you will learn how to combine like terms, in other words, how to add algebraic expressions. So looking at number 1, Ben has one big green square, 3 green rectangles, and 5 green small squares on his desk. Amadea has 3 big green squares, 2 green rectangles, and 2 small green squares. What do they have together? Now you might be wondering, why does it keep saying green? I'm seeing Ben's work right here. Ben's tiles are not just green, but remember, green is basically a way of saying that this is positive side of the algebra tiles. The red side would mean that it's negative. So you have one big one, 3 green rectangles, and 5 small green squares on Ben's desk, and then Amadea has 3 big green squares. It's helpful to notate that you have 3 of these, 2 of these, and then 2 of those. What do they have together? So you will not always be using algebra tiles at home, so a good way to do this is to draw them out like so. Notice that I am not shading in these tiles, because when you don't shade in the tiles, that means it's positive. We want to know what they have together. So if this is on Ben's desk and this is on Amadea's desk, that means basically we just have to combine them all together. So imagine us pushing the pile together of their tiles and finding out what they have together. So here's Ben's desk, here's Amadea's desk. We're going to add them together to find out what they have together. And so we can prove this by just drawing out our tiles. So 1 square, 3 more squares, 1, 2, 3, 4, 5 rectangles, and then we also have 5, 6, 7 little squares. All right, so that's how we show the tiles. But there's a way to do this using algebraic expressions and an algebraic equation. So Ben's polynomial, or his algebraic expression, is x squared plus, he has 3 x's, plus 5 small squares. All right, and then Amadea's algebraic expression is 3x squared plus 2x plus 2. That means when I combine these, I should really get 4x squared plus 5x plus 7. And you should see that that works. Here you have x squared and 3x squared. You combine those like terms to be 4x squared. You have 3x and 2x, which combine to be the 5x right here. And then you have this 5 and this 2, and they combine to be 7. All right, we're going to try another example, number 2. Now we have Jordan has 1 big green square, 3 red rectangles, and 5 green small squares on his desk. All right, so let's see what Jordan has. He has a positive one, so we don't shade it, 3 negative rectangles, and then 5 little ones. Anna has 3 big green squares, 2 red rectangles, and 2 red small squares on her desk. What do they have combined? All right, so again, imagine taking the tiles on their desk and just putting them all together onto one desk. So that's what we're about to draw. So whatever is on Jordan's desk, whatever's on Anna's desk, let's just combine the pile of tiles, push them in, and then find out what they have together. That means you have 1, 2, 3, 4 big green squares. You have 1, 2, 3, 4, 5 red rectangles. Notice that I'm shading them in because they are negative. We always shade in the negative tiles. And then you have 5 little ones and then 2 negative ones, which means I have to be very careful how I draw these. 1, 2, 3, 4, 5. These are my positive tiles. And then you have Anna's 2 little ones that should be shaded in. All right, so that's what they have together. Now let's come up with this algebraic equation. What is Jordan's expression? Well, Jordan has 1x squared. We do not write the coefficient 1 because that's redundant. And then he has 3 x's, but wait, he doesn't just have 3 x's, he has 3 negative x's. Don't forget that negative sign. And then he also has 5 positive tiles. 1 tiles. All right, Anna has 3x squares. She has negative 2x's. I can write it as minus 2x, or I can also notate it like so. Same thing. And she has 2 negative tiles. 1 tiles. All right, so let's figure out what this would mean. So they have x squared and 3x squared. That means they have 4 big squares. 1, 2, 3, 4. That is correct. All right. Together, they also have these 3 negative red tiles, these rectangles, and 2 negative red tiles. These are x's. So that means they have negative 5x together. 1, 2, 3, 4, 5. All right, now let's talk about what do we do here. So one of them has 5 positives and one of them has 2 negatives. Well, this is where we bring in the additive inverse. Additive inverse. Or zero pair. Basically, we know that when you have a positive tile and a negative tile, they cancel each other out. They are opposites. So you can take these off the desk because these amount to nothing. Take them off the desk and take these off the desk. That means you should just have 3 positive tiles. All right, because 5 plus a negative 2 is 3. All right, we have one more example. Let's look at number 3. Make sure you are pausing and rewinding if you want to clarify how to do some of this. All right, number 3. Alex has 2 big red squares, 6 red rectangles, and 3 green small squares on his desk. Raven has 4 big green squares, 2 red rectangles, and 5 red small squares on her desk. What do they have together? Now would be a good time to pause and try this problem out by yourself, showing the tiles as well as the algebraic equation. All right, assuming that you already paused, let's go over the answer. So when you combine what they have together, you should have 1, 2, 3, 4, 5, 6 squares, but be careful. You have 2 of these red ones, and then you have 4 unshaded green ones because that means that they are negative. If you are doing this at home, you don't have to use colored pencils or markers. You can just make sure you are shading or not shading to denote whether something is positive or negative. And then we have 1, 2, 3, 4, 5, 6 red rectangles. These are negative x's. And then Raven has 2. And then we have 3 positive red squares. Oops. And then we also have 5 little red squares. These are our 1 pieces. I'm going to use a thinner marker. 1, 2, shading because they're negative, 3, 4, and 5. All right, so what do they have together? Well, let's just talk about the additive inverse here. What here could make a zero pair? If I have 2 negatives, the opposite of 2 negatives is 2 positives. This would be called a zero pair. So I can actually just take this off the desk. All right, those cancel each other out. And then I have no more rectangles that I can combine, but I have a zero pair here, a zero pair here, and a zero pair here. These can go off the desk. All right, so our answer when we write our algebraic equation should be 2 positive x squares, and we have 1, 2, 3, 4, 5, 6, 7, 8 negative x's, and then you have 2 negative 1 pieces. Let's just make sure we have our algebraic expressions for the other 2 so we can check if we did that correctly. Negative 2x squared plus negative 6x plus positive 3 for Alex. And for Raven, we have 4x squared plus a negative 2x plus a negative 5. All right, negative 2x squared plus 4x squared is in fact 2x squared. negative 6x and a negative 2x is negative 8x, and then 3 plus a negative 5 is negative 2. Thank you for watching part 2. Stay tuned for part 3.